Here we are at the last video of this series, getting Libero and soft console working to allow the MSS RISC processors to communicate and control the FPGA fabric or gateware in the Polarfire FPGA. All right, so this is the last step. And so previous step was the biggie, getting the the processor to write to the fabric. This one is more of a mop-up where we're just going to add in something to allow PuTTY to send over some commands or something that allows us to change the blink rate through PuTTY, which is kind of cool. So let's see if we can get this final step done. Minimize. All right, so here is our code that we used to make it blink fast. Worked pretty good. So let's Control C that. Um, so I don't know if we should go over this again, but essentially we're setting a pointer to this address of 4 6 zeros and a 4. Nice palindrome. Um, uh, And this is like so this is the address inside the fabric. Previous episodes, we looked at how to find that by going through the using Libero to track down the logic that addresses blocks. Um, and so we know how to do that. Here it's just setting a value to like around 1/10 of a second. We talked about how we came up with that value. Um, And here is where we assign that value of 1/10 of a second to the address, to the contents of the address inside of the FPGA fabric gateware. And this is what we're going to use. And how are we going to cheat to get this thing done quickly? All right, this one here, if you remember from our first video on soft console, this is in this endless loop where if you're a 1, it prints out one message. If it's a 2, it prints out a different message. If it's a default, it prints out a different message. And this is just polling around, around and around and around. And here, this RX size 0 greater than 0 means that there's something to work on. All right, so let's go and let's hit this and let's try to just sneak something in. We'll leave all the other code there. That's okay. Doesn't bother me. Something just hit my window. Um, oh well. Uh, More important, we've got to finish this video. Okay. All right, so let's see. Let's see if is digit. So the code that's existing for the UART, or however the UART demo was, has this buffer in location 0. So if it's a digit, meaning 0 through 9, what we're going to do is we're going to go in and we're going to just change the blink rate. Because and so we'll have this case, why not 10 blink rates going from 0 to 9, and 0 is off, 9 is the fastest. And let's see, squiggle, close that off. And then new int 32T. Something is going on outside. Control V. It was in my base buffer. Good luck. Minus the ordinal value of 0. And so what that does is it'll take whatever ASCII character minus 0, and that will give you an integer offset. So it'll, blink rate will be a number from 0 to 9. Then what we'll do is we'll take this guy here, blink rate C times. All right. So this blink rate local was really like a tenth of a second. So this will make it so that if you put in a 9, it'll be 9/10 of a second. If it's 0, it'll turn off. Geez, is that all we're gonna do? I think so. If that works, I'm done. So let's do a Control S. Why wouldn't it work? Well, a lot of reasons, but I think it should be fine. So let's go up to this hammer and oh, see, are we running still? No, so let's stop this. Sometimes it gets a little hissy when we start compiling when we're running. So I'm going to stop that guy. It looks like he stopped. Also, I'm gonna so the Icicle board is still blinking fast, even though the processor stopped, because the FPGA fabric continues running. It seems like it only stops when the MSS starts powering, starts coming out of reset, and then it needs to hit that uh, routine. And it seems like a very important routine that we should remember. This guy has to run after the MSS gets started. This routine has to run like it is here to bring the fabric gateware out of reset. We don't want to forget that. So then we come back down to our uh, specific caps. Um, and UART, ports 10, ports of link, range, where 0 equals off and 9 equals approximately 0.9 seconds. That's almost clear. Good. Let's give, let me reset the board. Turn the board off, turn the board on. Nice slow blink rate. It's very relaxing. And let's hit the left click the hammer. Build that limb debug image. Something from the ground in there. What was that? Oh, this digit is not defined. What's that? I think it's C type. C type. I think that should do a Control S. I think C type defines declares or whatever they call it. Is digit. And left click on the hammer again. It's good to watch it scroll by to see if you get any funny colors, because that would have been a nasty error to debug. Okay, so that's compiled successfully. Blink rate is slow. Now we're going to click the left click the run. The blink rate has just stopped. And still stopped. We're at a resume point here. I'm going to click on resume. Do I have PuTTY connected? I'm not sure if I do or not. Nice manager. Okay. Let's click on ports. Okay, we got all these Silicon Labs. So we want COM 18. All right. Let's see this here, COM 18 for the first bridge, which I believe corresponds to the E51. So that's COM 18. Let's close in. And now let's bring up PuTTY. Let's click on serial, COM 18. Change the speed to 115, 200. So we want COM 18, 115, 200 serial. And click on open with a left click. All right. It's kind of like minimize him over a little bit. And something else popped outside my window. I don't know what's going on. I don't really like it. Maybe get this video going before so I can investigate outside. Okay, now I think all we have to do is resume. Hopefully something comes on this COM board. Oh, great. That's awesome news. So the blink rate is now super fast. I'm going to put in a 9. Oh, yeah, it slowed way down. Let's put in a 1. Fast. Put in a 0. Stopped. Put in a 1. Fast. Put in a 5. Medium. Put in a 9. Slow. This thing's working. So now, even though our messages are garbage here, we can type in 0 through 9, and that gives us 10 levels of blink speed, controlling, so PuTTY over UART to the MSS RISC processors, to the E51, to the FPGA fabric over the FIC3 fabric interconnect APB bus, to the Blinky APB underscore Blinky.V, out the LED, through some of the hierarchy, out to a pin on the FPGA, across the board to the LEDs, and they are blinking. So everything seems to be working just great. This wraps up this many part series on Libero and Polarfire, Icicle, and Soft Console. That's all. Bye.